Hello friends, good morning. Welcome to my channel Essentials of Management. Friends, motto of this channel is evolving high standards of learning, management science in general, and that of environment, health and safety management in particular. So today we are going to continue with Industrial Safety Management series. We will have discourse 16. Here we will be discussing the topic of safe system of work, that is SSoW. We will be discussing part 1 of the 2 parts where we will learn basic understanding of SSoW. Now, as you know, one of the employer's responsibilities is to provide and maintain a safe system of work. So, firstly, they have to give the safe work environment, and safe system of work is a part of that safe work environment. So, a safe system can be defined as a planned way of doing a job safely and without risk or minimum risks. It takes account of the steps involved. Means when you do anything, there is a certain process and there are certain steps involved. So, what we do, we take into account in consideration all the steps involved. For that we do the job safety analysis. Whatever the associated tools or plant and equipment, so what we are using, which type of tools, which type of plant or equipment or machines, and substances, that is material, and also of the people involved, including consideration of their skills and experience. So exactly you try to remember, we discussed about the man, machine, material and energy interface, and then we also talked about the skills and experience of the people when we were discussing the difference between the hazard identification and the risk assessment. Please visit the respective discourses to brush up that. So, hazards are identified in advance. So, what is that? The process is the process of SSoW. Establishing the process is hazards are identified in advance, and first you try the elimination, and if not possible, steps are taken to minimize it during the entire work schedule. So, whatever the work schedule is there, you see that the hazards are identified, either they are eliminated or they are minimized to the acceptable level. Simply speaking, this is the way we do things to reduce the risk. Now friends, here we have to understand mainly that there are 2 types of operations. One is routine operation and one is non-routine operations. Now, safe system of work is required for the routine operation also. So, there we have the hierarchy of control, and there we have the methodology or the SOPs, instructions and so on. But in case of a non-routine work, it is very difficult to decide upon the standard operating procedure or many of the controls which you establish. Say if you are working on the maintenance of a machine, so you remove the guard, so you disable the interlocking arrangements, right? So here the work become more risky, and here we need more precautions in terms of safe system of work. So it is a formal procedure for doing a job in a safe way, which results from systematic examination of a task in order to identify all the hazards. So we saw that you have to completely see the process, do the job safety analysis, and then what are the hazards are there, they are identified. It defines a safe method to ensure that hazards are eliminated or risk is minimized. It combines materials, people, plant, equipment, task and environment. All these things we discussed in the last slide also. And it may include the physical layout of the task, means the layout of your workplace, where you are working, your workstation, the sequence in which the work is carried out. So right from start to end, whatever is the sequence of operations, tasks, actions and so on. The provision of warning and notices. So you have provision of, or you can say extra provision of warning and notices. Issue of special instructions which are there in the permit to work systems. Provision of safety equipment and of adequate safety precautions. So whatever is required to see that people working on such non-routine job, they are safe, you do all these things, you take all the steps for doing that. Now many hazards are clearly recognizable and can be overcome by physically separating people from them. For example, by using guarding on machinery. So you create a barrier between human being and the machine. A SSoW is needed when hazards cannot be physically eliminated and some elements of risk remains. To mitigate or face that residual risk, SSoW covers a spectrum of controls varying from use of rules, for example, how to use the ladders, thorough procedures, that is plant operation, to permits to work, then lockout, tag out procedures and appropriate PPE and more. So all these permit to work regime, LOTO regime, PPE regime are the part of safe system of work. Remember that particularly non-routine work including maintenance work as well as some normal operations need SSoW. So normal operations also need SSoW, but non-routine operations need more safe system of work, more elaborate. When we consider how to safeguard hazardous activities, we need to use a combination of both engineering controls and a safe system of work. For a production operator, the ratio is usually 80-20 engineering control and 20% safe system. However, when considering maintenance activities, the worker is generally less able to rely upon engineering controls. We discussed that he has to remove the guards, he has to dysfunction the interlocking arrangements. So he is less able to rely upon engineering controls to achieve safety, and more emphasis is placed upon the safe system. Indeed, the first thing the fitter does to gain access to where they have to work may well be to remove the guard, which gives a good standard of protection to the ordinary production operator. So try to understand the difference between a routine operation and a non-routine operation. The proportional relationship is that reversed as illustrated in next slide. A ratio of 20-80 engineering control, safe system would be typical, means where you are doing non-routine operation and where the regular controls, engineering controls are only reliable up to 20% and 80% you have to rely on the safe system of work. It follows that safe systems are especially important in maintenance and where tasks may be infrequent and risk not readily understood. So sometimes it happens that you cannot judge the risk properly and you cannot have the risk assessment. You are not very sure about that. So with normal process operations, the balance is weighted towards engineering control. So in routine day-to-day production operations or other operations, you rely more on engineering control. In maintenance and similar exceptional activities, engineering control is less practical and a safe system of work therefore becomes of a paramount importance. So there are line A and line B like this. So when you are doing non-routine operation, you rely more on safe systems, and when you are doing routine operation, you rely more on the engineering controls. So it is the 80-20 formula suggested by the experts. So where you require SSoW in particular or more. So all hazardous operations including maintenance and cleaning, electrical isolation, where you have to do the electrical isolation, that LOTO, that is lockout tagout procedures, electrical testing, work on roofs, use of hazardous materials, lifting and handling, cutting and welding, confined space entry, and particularly contractors activities, and many more. So these are the various activities. Even working at height is also one of that operation where you need more precautions and you rely more on SSoW. So here we try to understand in this discourse what exactly the SSoW is and where it is predominantly required. So thank you for watching. Friends, you can resume viewing. So switch on to discourse 17, where we will see the further part, that is designing a safe system of work. Friends, please do not forget to like, share, comment and subscribe to my channel. Thank you very much. Have a good day.